Assalamualaikum and good day everyone. Today we will learn on chapter 3, Valuation Theory for Pension Plan. As an introduction, pension plan is a major application of multiple decrement models that we learned in last chapter. In this chapter, we shall consider basic methods used in calculating the actual present value or the APV of benefits and contribution. So we have benefit and contribution for pension plans. The participants of a plan may be the employees of a single employer, or they may be the employees of a group of employers. Upon retirement, typically provides pensions for first age and service or disability. And in case of withdrawal, they may be written off accumulated employee contributions or a deferred pensions. For death occurring before the other contingencies, they may be a lump sum or income payable to a beneficiary. So this is death before the retirement age during the service. Payments to meet the cost of the benefits are referred to as contributions, not premiums as for insurance. So for insurance, we have to pay premium to the insurance company. So individual insurance company, so the individual have to pay premium to get benefit from the insurance company. However, in pension plan, the participant will give contributions to pension administrator, and the pension administrator will give the benefit to the participant. So a pension plan can be regarded as a system for purchasing deferred life annuities, so payable during the retirement, and certain ancillary benefits or the supplement benefits by some form of temporary annuity of contributions during active service. And then the balancing of APV of benefits and the contributions may be on an individual basis, but more often is on some aggregate basis for the whole group of participants. So we shall concern with only the separate valuation of pension plans, actual present value of benefits and contribution with respect to a typical participant. So the basic tools for valuing the benefits. So we have two kinds of pension plan. First is defined benefits. So in our country, we call it as government pension for government servants. And second one is defined contributions. So in our country, the EPF for the private sector employees or the government servant who choose to contribute in the EPF. So in this course, we just cover on the defined benefits. So there are three forms of pension benefits. We have, first, we look at age service retirement benefits, where we receive the benefits when we reach retirement age. Second one is disability benefits. If we involved with accidents during the service and we got disability benefits or withdrawal benefits, so we withdraw within the service years. First one is basic function that we have to go through. So the APV future contributions must equal to the APV future benefits. So this one must be balanced. So we have three kinds of age. So the entry age, when we starting our contributions, and the valuation age, which is the current age, we denote as X plus H, and the future age decrement X plus H plus T. So the decrement can be withdrawal, disability, or age retirement service. Second one, how to project the salary. So we have to project the actual annual salary now to the retirement age, the estimated annual salary at age X plus H plus T. So now is X plus H. So the notation for the actual annual salary at X plus H is AS at age X plus H, and the expected annual salary is ES at age X plus H plus T. And SY is the salary scale function, is usually assumed to be a step function constant over each year of age. So this is the formula to calculate estimated annual salary at age X plus H plus T. Let's try example 1. Assuming salary grows at 2% per year as y equal to 1.02 the power of y, and calculate the expected of salary at age X plus H plus T. So we use this formula and we substitute the salary grows at 2%. So this is how we calculate the expected salary. Now we look at example 2. A person aged 40 has an annual salary of 50,000. What is estimated salary at age 50, assuming salary grows at 7% per year? So this is the information that we have to consider. So age 40, which is the current age, X plus H is equal to 40, and the annual salary now is 50,000, and we have to calculate the estimated salary at age 50. So X plus H plus T is 50 using the scale function 7%, and this is how we write down the salary scale function. And then we use this formula. So this is 50 is X plus H plus T, and the current age is X plus H is at 40, and then we substitute the values inside the formula, and finally we get 98,357 ringgit 57 cent for the estimated salary at age 50. Now we try example 3. A person aged 40 has an annual salary of 50,000. Suppose that salary scale as y is equal to this one. What is the estimated salary at age 50? So X plus H is 40. So the annual salary at age 40 is 50,000. And we have to find the estimated salary at age 50. And we use this formula as example 1 and 2. And we substitute the salary scale function inside. And finally, we got 102,291 ringgit 78 cent. Next part is we look at the contributions. So let's assume the contribution continuously at annual rate of 100%. So C is 100%. C stands for the contribution is 100% of the salary. So X, where K is equal to 0, X plus H is the current age or the valuation date starts, and X plus H plus T, and then the omega is the age of certainty for pension. So after we derive this formula, so we get finally the APV for X plus H is this one. So let's try example 4. Contributions to a pension plan of 3% of salary are made throughout an employee's working lifetime until age 71. All payments are made at mid-year. The salary scale functions is as x equal to 1.2 to the power of x is constant within any year of age, and employee now age 44 has a current salary of 28,000. If TP44 tau is equal to 1.08 to the power of negative t and the interest rate is 0.08, calculate the APV of future contributions for this employee. So now we take the information given. So X plus H, the current age is 44. The contribution, the C is 3%. And the scale function is 1.2 to the power of x, TPX tau, and I is equal to 0.08. And the annual salary at current year is 28,000. And omega is equal to 71. So we use this formula. So we take out the constant outside to make it easier. And then the upper bound is omega minus x plus h minus 1. Because it is mid-year, so this is half. And then we substitute the values inside. And we simplify the equation in the summation, and now we take out all the constant outside and we simplify the equation and we get this one. So we just leave this one in the summation. So to solve the summation, we can use the accumulated future value, or we can also use the geometric series function. So let's say we use the accumulated future values. So we get this one. And finally we get 30,345 ringgit 85 cent. So similar if we use geometric series and substitute here, and we will get the same answer.